Okay, so this question, I'm just going to do a simple question into calculating aspects of linear motion of a car or a vehicle. Okay, so I'm going to start out by writing out the question. I'm going to be putting in the variables I'm going to be using as I'm going along, and then you can see that the variables that I put in, if I put them in right, will automatically appear in the variable section, where we can edit them later. So I'm going to say a vehicle, and I'm going to make the vehicle my first variable. So to make it a variable, I'm going to put it in curly brackets. And you can see that as soon as I've done that, in the variables tab, I've got this exclamation mark. That's because it's set up this vehicle here. And we'll, again, like we're saying, we'll deal with that in a bit. Travelling at, and the first is our initial velocity we want, and our initial velocity here is going to be in kilometres per hour, and I'm going to put the kilometres per hour in latex, just that makes it look slightly nicer, so km per h, and then we're going to do a displacement, so it is s. And again, I'll put the units in latex, meters from a speed, limit sign of, and again for this next bit we're wanting our final velocity is v, and again that's going to be kilometers per hour. And that sets up this scenario for us. Okay, and then we're going to go into our variables here. And the first variable was a vehicle. I've called it a vehicle. Well, let's say we're going to have a car and a lorry. So it's going to switch between either car or lorry. So strictly speaking, that's called an array that we're going to put this into. So to say that our variable is an array, the value needs to be in square brackets. And it's a list, not an array. It's a list. So open up those square brackets and closing them in the variable section means that we're starting to write a list. And we're going to put string values into this list. So string values are just words, basically. So I'm going to put in one that's a car. And I'm going to put a comma to separate it out. And then I'm going to put a van as the next one. And then if we go back to the statement now, if we preview this, you can see it's got the whole list there, but we don't want the whole list, okay? So we just want one of these. So to make it, just pick one of these. We're going to say we just want a random one from this list. And you can see now down the bottom it's got van. So again, if we go back to the statement and preview this, it says a van. If we do it again, regenerate values, it'll switch between, sometimes it will say car, sometimes it will say van, okay? Our initial velocity, we just want a random variable for this, and we want for this we're going to have it as an integer value, and we'll just make it start at 50 and go up to 100. Okay, so that's just going to give us a random value. This one's 59, between 50 and 100. For our displacement, again we're just wanting a random value between, let's say, 75 and 200 for this. And our final velocity, we'll do a random value let's say between 30 and 80. Okay, now this question here is going to get the person driving the vehicle to slow down, okay? So to make that happen, our initial velocity, our u, has always got to be greater than v. We can do that, we can specify that we want these two variables to be set up that way. So we go into variable testing here, and this variable testing bit is a bit that lets us put in conditions. So the condition that we want to satisfy is that this, we start off with our u, our initial velocity, has got to be greater than our v. Okay. Sometimes it's useful to test this to see how often that happens. For u greater than v, I can't remember how we set it up, but it will tell us how probable it is. So this time the condition is satisfied 81% of the time. Okay, so 81% of the time has done that. So it's only going to pick numbers out of that 81% of runs that it does. Okay, so it did 100 runs there, or sorry, it did 600 runs there. There's no errors. So, you know, over 400 of them would have been numbers that fill that criteria. So that's the ones that it's going to do, pick one from. So, yeah, if we go back now to our variables, like I was going to do next, is we want to set this up as a group. So these are like our initial conditions, really. So if we click the button that says new variable group, I'll just call that initial conditions. And this is just all about the way that you want to organize your data, and we can just click and drag. I'm doing this on my iPad and it's not working too well on it. But on a laptop you can just drag them up. It's not one to do it. Into the correct bit. Oh, there we go, that's it. There we go. So that's got our variables in our initial conditions bit. And again, if we go back and just look at our statement again, just to check that it's working, it seems to be behaving properly. Okay, so the next thing that we're going to do is we're going to ask the students to convert those values into meters per second rather than having kilometers per hour. We're going to get them to convert them into meters per second. So we're going to have converted values. And again, this is just all about keeping your working space tidy, really. So we'll have a value of u meters per second. Again, for this, you've got to, you can't have spaces in your title. You can't also start a name of a variable with a number. It's got to be a letter to start the name. But apart from that, you can call it anything you want. So this is u meters per second. And this description bit, you can put in here a wee note to yourself just so you know what the variable is all about. And the value for this is just going to be whatever the value for u was, and we're going to divide it by 3.6. Okay, and we're going to do the same thing for the final velocity, the v. So m per s is going to be v divided by 3.6. Okay, and then the other thing we wanted the students to do, in fact, we'll put these in a part here, so we'll get them in here. For the first part here, we want to get them to do two things. So we really want two boxes. You could just put in number entry, but I think I'm going to go to the bit that says gap fill. We're going to put in gap fill. So gap fill lets you put in more than one gap in each part. Okay. So the prompt is, for the first bit, I'm going to say convert the initial velocity to appropriate units to use in a calculation. And again, I'm just going to put a wee bit of LaTeX for the U, just to make it look fancier. And when you're putting in a gap, in the prompt box here, in this box here, we need to put in where the gap's going to go. And the way that you put in where the gap is you use square brackets, and you do 2 of them, so square brackets. And then we're going to put in the number 0, because that's the first gap, and then we're going to close those square brackets like that. Okay. Convert the initial velocity, and we'll say, and convert the initial and final velocities to appropriate units to use in the calculation. And so when it comes to V, we'll just do the same thing again. Equals. But this box is going to be box 1. Okay. Now, we want to put in our answers, so we're going to press this button that says add a gap. And it's a number entry really we could put a mathematical expression. It doesn't really matter which. When I say it doesn't matter which, there's slight differences between the two. I think I'll show you how it works with mathematical expression, okay? So for mathematical expression, the correct answer for this is our variable U in meters per second, so M per S. And I've put the U M per S in curly brackets, and the reason we've done that is because it's a variable, and this tells the Numbas system that you're putting in a variable, putting in the curly brackets. We want to show correct answer on reveal. We'll show the score and feedback icon. Okay, next thing is the marking algorithm. We don't actually need that. Next thing is accuracy, that's what I was looking for, sorry. So in the mathematical expression, if you're putting in a numerical answer, you can either mark it to how far off you want the answer to be. Okay, so absolute difference just means, it just adds or subtracts a certain amount from the answer to make it within that range. Okay. Relative difference gives it as a multiple of that answer. So you might want to do, if it was in 1% of the answer, you just do 0.01, and that would mean it would set it up in between. That makes it 1% would be 0.01. That would make it within 1% of the perfect answer. Decimal points, you can put it to decimal points, and that's just we just change that to 2 if you want 2 decimal points and that kind of thing like that. Okay. Or you could do it for significant figures as well. Okay. So you just choose which one of those that you want. I'm going to do this one. I think we'll do this as... No, we'll just leave it as decimal points. So that was the first gap there. We'll do the same thing for the second gap. This time we'll do it as a number entry just to show the difference. So again, we'll have this one as 1 mark. So the maximum accepted value for this would be V in meters per second per S. And the maximum, we'll put in the same amount. Now for this, there's going to be no leeway in the answer. It's just going to be right or wrong to 2 decimal places. But if you say you want to mark this within, say, 1% of the true answer, you could just put in here times 0.99 or for the minimum value, and then times 1.01 for the maximum accepted. And then that means any number within that range there is going to be accepted as correct. Okay, so I'll leave that there just now, like that. And again, you could put that in here, and then you could also have correct 2 decimal places. Like that. The display answer thing, if you want to change what the answer is displayed, just now it defaults to the midpoint of these two, but you could make it, you could change that to anything you want. We don't really want trailing zeros, and that's that there. Okay, so now if we run this, hopefully it should work. And you can see the slight difference between the two is just that you've got the prompt there for the one that was a numerical answer, and you don't have that prompt, the one that was a mathematical expression. Okay. You can also see here, car travelling at 59 kilometres per hour is 200 metres away from a speed limit sign of 58 kilometres per hour. So obviously it's just going to have to decrease by 1 kilometre an hour. You might not want that. You might want to put in a bigger difference. And again, to put in a bigger difference between the two, you could do that in the variable testing. Okay. So you could say that U has got to be bigger than, I don't know, V plus 5, right? So that means that it's always got to be, at least 5 bigger than whatever your final velocity is. Okay, so if we go back to that, they've got the first part there. The next thing we're going to do is we're going to get candidates to choose the appropriate equation. There you go. So we want to have a list of equations that the student's got to pick the correct one they're going to use for doing calculations from. You could do a different variable for each equation, so we'll do that. And this one here, when you're putting in an equation, generally speaking, you want it to be an expression that you're putting in, because that means that it's something that the system can use to calculate values with. Although saying that, actually thinking about it, for this one here, I'm just going to put them in as strings just now, okay? And then we'll get them to convert it to an expression later on when we want it to actually do some work with it. So the first one is going to be v squared equals u squared plus 2 times a times s. Okay, so you can see that it's generated a string value here. Okay, then we'll do an alternative velocity. V equals u plus a times t. And we'll put in a displacement one as well. S equals u times t plus a half a times t squared. Okay. Now, to get the students to pick this, we need to go and we're going to put in another part. Another part, and this one I'm going to choose one from a list. Okay, and here are a list of choices. We'll give the student a prompt. We'll say, for this bit, choose the equation most suitable for calculating acceleration, deceleration in the problem. Okay, something like that. Then we'll go to our choices. And in here, we're just going to put in our equations, okay? Now, they're variables, so we're going to put them in curly brackets. Okay, but like I was saying, we really want them as expressions. And actually, we really want them not just as expressions, but we want them as LaTeX outputs, right? If we do them as expressions, that should be fine. So if we just do in here expression, and then the first variable was just velocity. Okay, and then if we click preview, that should see us what it's coming out. You can see it's not really coming out as we want it just yet. But if we then put into this LaTeX just before it, that converts it into the LaTeX kind of output. And if we do it this time, you can see that it gives it a much nicer how we would want it to look. Okay. So I'm just going to copy this. I'm going to add another choice, and we'll put in here, paste. But this time we don't want it to be velocity, we want it to be just the alternative velocity one. And in this one, we don't want it to be velocity, it would be displacement. Okay, I'll just check that they're both working. Yep, that looks good. That's good. Okay, so the other two equations, we're not given the time here in the question, so they wouldn't be the ones would be most appropriate to use. So the one that is a velocity equation, so that's the one we assign 1 mark to. Okay, I'd normally tick shuffle order of choices. It just means that they appear differently all the time. And again, if we go back to our question now and we run this, just to see how it's looking. Down here we can we've got the equations here, you can tick how you want them. A couple more options with this. You can go into marking settings here. It doesn't need to be radio buttons, we can have them as a drop down list. So that looks like that. And you can just tick which one you want. But again, it doesn't really, I'd maybe stick with radio buttons because, you know, in this iPad certainly it's not coming out that nicely. But again, it's something you can just play about with. So radio buttons. You can put them in a column if you want them to be in one column or more columns. So again with that. And that just presents them in that fashion rather than across the way. Okay, but I was quite liking it, just having it as laid out sideways. So there's that like that. Okay. Right, so that's that part there. Now we want to do some calculations. So we need a new variable. I'll actually put it in a new group. Okay, so in this one here, the first calculation we're going to get the students to calculate the acceleration or deceleration in this case, but we'll call it A for acceleration. So for this one, our acceleration would be v squared minus u squared over 2s. So we'll put that in, v squared minus u squared over 2 times s. And again, just watch out for your brackets, put them in the right place so the calculation works out. You can see it's a deceleration that's coming out. It should always be that. Generally in the variables, it's always a negative number that's coming out. The equation to work out the time will be v minus u over our value for a. Okay, so now we can go and get them to do these calculations. So I'm going to stick for this one, for the acceleration bit, I'm going to stick in part B. And I'm going to add another we'll have to add another part. So for this one again, it's just going to be, I'm just going to go for number entry. So for this is going to be calculate the acceleration. Okay, so calculate the acceleration. In fact, you know what I'm going to do? I'm going to change this to it being a gap fill one. It's going to be a gap fill number entry one. If we go back to the top of the gap, here it says part C gap fill, calculate the acceleration. We've got our gap here, and let's just go here and say $A equals. And this is going to be gap 0, it's going to default to gap 0. Okay. Calculate the acceleration. And in the gap, our minimum accepted value, let's do a times 0.99. And maximum value would be a times 1.01. And we'll make it 2 decimal places again. We don't want it to trail on zeros. Okay, the reason I made this one a gap fill is because I'm going to add another gap now. And this gap is going to be choose one from a list. And this is going to be for our units. Okay, so I'm going to put in some choices. First choice, we'll do the correct one. So acceleration is meters per second. So in fact, I'll do it as a latex, so meters per second squared. Okay, that's the correct one. Then we'll put in a couple of misleading ones. So let's put in meters per second. And let's put in kilometers. Okay. And we want to tick shuffle order of choices. This one, let's put as a drop down list just to see what it looks like. And if we run this now, it probably gives an. We haven't actually put it in, so we've got the acceleration bit, we've not actually put in a gap for this. So we need to go back to the prompt. Calculate the acceleration, choosing the appropriate units. Yeah. Okay, and so just after that, it's gap 1, so we do double brackets, 1, and then close our double brackets. You can see that that's made that bit happier. So if we run, now when we go and look at the preview, you can see there I think it's because it's on the iPad it doesn't like it. It's kind of doing it as a double, kind of repeating it. So maybe I'll just go back and make it into radio buttons again. Okay. There we go. So obviously if we do that, it should mark it right. And the other ones mark it wrong, that kind of thing. Okay. Okay, so now the next part is really similar. We're going to get them to choose, from part B, we're going to get them to choose an equation, because it needs to be a different equation to work out the time. And for part C, again, we're going to get them to copy it. So what we can actually do is we can just copy this part. Okay, so I've just clicked on part B and best press copy this part. And then we can see this is pretty much all filled in for us now, right? So if we go to our parts for this, we've got our choices here. But this time, the one that we're actually wanting to pick is probably going to be the alternative velocity one, v equals u plus at, because we've already worked out the rest of everything else. So we'll make this one 0, and we'll make this one 1. One other thing we need to do is need to watch the prompt. Calculate the equation most suitable, so choose the equation most suitable for calculating the time, or the time to decelerate in the bottom above. Again, you can just choose whichever word is most appropriate for you, and that's about that. So now if we run this, got part D here, choose the equation most suitable, and this time it's v equals u plus at. There we go. Right, and the part C, the bit where we had to calculate acceleration, well, I'm just going to copy this for our part E. So to calculate the acceleration, we want to change that to calculate the time taken to decelerate, choosing the appropriate units. Okay, so we want to change this A here to a T. Our number entry is going to be our variable T, which is just here. And again, we'll just leave everything else the same. And the choose one from a list point. Well, we do need to add in a choice here because, time's measured in seconds. So let's just put this in as S. And that's the correct one. And let's take out the kilometers. Just preview what the S looks like. Yep, looks good. Okay, so if we run that, we've now got something that is looking pretty good. If we press review answers, instead of doing all the calculations yourself, you can see that it says this is the correct one for part D. The expected answer is 1.85. You've got minus 12.97. It's doing all the things that it wants for you to do. You can see I probably would, maybe if I was rewriting this one out, maybe make this U and as a number one, just so it rounds it to 2 decimal places. Although, saying that, you can kind of force it to be that. If you want U to be 2 decimal places, you can use something called prec round, precision rounding. So you just go prec round the function there, of whatever your number is, to 2 decimal places, and that will automatically round it to 2 decimal places, that kind of thing. Okay. There is a list of functions. in the help. Up here, there's a help menu. And up in the help menu, it's got a bunch of stuff showing you how to make your questions. It's a good resource. It tells you about LaTeX notation. The code that we're using to write these questions is called GME. And this GME tab is really useful. And here, the bit that I would use most of the time when I'm writing these myself is, and here somewhere, yes, it should be in the GME bit. There should be a function, yeah, this bit here, this function library sort of thing. And that gives you a list of all the functions that you can use to manipulate numbers. So if you want something in radians, you just need to type radians, put brackets around it, that converts into radians, for instance. And there's a bunch of stuff here, lists, matrices, you name it, you can do it. Yeah, so the help tab is really, the help section is really useful.